In this video, we are going to take a look at BGP TTL Security. When it comes to TTL Security, this is kind of a cool feature which allows us to basically dictate how many hops we should see from a eBGP peer when we go to form one. So normally with BGP peerings, you have a default TTL of 1, which is as far out as you can form a peering with another eBGP peering. Well, you can do a disable connected check in iOS, an ignore connected check in iOS XR. So there's multiple ways that you can disable that check and then do like an eBGP multi-hop and things like that. But those really don't prevent the issue that could be formed with a BGP peering. Now, you can't form a BGP peering. There's a big caveat with this, and I'll talk about it here in just a moment. You can't form a BGP peering unless both ends agree on it. Now, the caveat being is you could use the dynamic neighbors capability and form the adjacency, but that assumes that you've taken into consideration where the traffic is going to be coming from. Now, normally when you form the peering, you specifically state the IP you're going to be forming the peering with. Maybe you're doing the update towards loopback 0 or some other address. You're basically telling it all the information it needs to actually go out there and form the peering. All that is great. What it doesn't do is it doesn't take into account that valid eBGP sessions are established between connected interfaces or loopback addresses. It enforces that receive TTL should match a specified value. Normally, it will. If you don't do anything with BGP, it will enforce the TTL of 1. If you disable that, it ignores it. If you go in and you use multi-hop, you're saying what the outgoing TTL value should be. When you're doing TTL security, you're saying what is the TTL when it enters the router. So if I say a peering should be no farther away than 5 hops, well then if a peering comes in and it's more than 5 hops away, then there could be a problem. Now the whole point of this is to prevent DOS attacks from non-directly connected neighbors by setting the receive TTL to the specified value. Now, TTL starts at 255 and decrements down to 0. 0 being that it's going to drop the packet. Well, if you go in there and set it to something very, very high, which means you set it to, something very, very high, 254, 255, something like that, you're going to give it a peering up to 250 hops to jump before it's going to hit you. The problem with that being is the peering can only be 3 hops away. So when enabled, sets the outgoing BGP packets to a 255, and you specify what the incoming should be. Does the opposite of what eBGP multi-hop does. So, and they cannot be you, and I know what you're thinking. Well, I'll set one to be one and one the other, and I can guarantee that it'll come back in, certain out. Doesn't work that way. You can't set eBGP multi-hop and TTL security on the same neighbor statement. It will not work. Now, in my testing of this, it does not work on iOS XRV in 5.3 code. It's not a supported feature. I cannot get it to work. I have looked at debugs. I've looked at Wireshark. I've even asked friends of mine that have a CCIE in service provider and took the service provider version 4 lab, and I asked them. They didn't really have an answer for me. I think it's just a limitation of the of iOS XRV in this particular case. So we're not going to look at it on iOS XR. We're going to look at it on just regular iOS. I know it's supported on the CSRs. When I was studying for CCIE route switch, I used it there for just testing out and seeing how the stuff works. So what we're going to do this is we're going to take a look at it from the perspective of R11 to R15. Now we're going to specify how far this is away, and we're going to form a peering off the directly connected interfaces, which means the 11.12.0.11 and the 14.15.0.15. Now before we go any further, I did some testing on this just to make sure that I knew what I was talking about here. And so we're going to do this on 11, and I'm going to go ahead and ping 14.15.0.15. Can I ping it? I can. Can I trace route to it? And numerically, I can get there. That means I'm 5 hops away. That means from my outside interface pointing towards 12, and on 15, my outside interface pointing towards 14, there's 5 hops in between there. Now, that's 5 AS hops. In this case right here, or technically that's 5 router hops. there's actually only 2 AS hops. So what I'm going to do here is on this connection, this is a brand new peering, by the way. I'm going to type in router BGP11. I'll type in neighbor of 14.15.0.15. Remote AS is 65,000. Say the TTL security is going to be hops of 5. And I'm going to say that the address family IPv4 unicast. And I'm going to go ahead and activate the neighbor. Now if I type in do show IP BGP neighbors for 14.15.0.15, pipe include hops or TTL, it's telling me the neighbor could be up to 5 hops away. This is going to be how we verify that the configuration is working correctly. So I'm going to go over here to R15, and we're going to say, all right, buddy, let's go to global config, type in router BGP 65,000, neighbor of 11.12.0.11, remote AS of 11. We're going to come up here and type in the TTL security of hops of 5, address family IPv4, and we're going to come in here and activate the configuration. Now we're going to do a do show IP BGP neighbor of, and there's the adjacency, neighbor of 11.12.0.11, pipe include hops or TTL. And there's our information right there. So the aspect that we're looking at here is, and you can see it did flop on me there for a second, and I don't use this command very often, and it is flaky, so just be careful of that. I just want to make sure that everybody understands that these commands are how the technology will work. Now it says right here that the explicit congestion notification is disabled, and the minimum incoming TTL 250 and the outgoing is 255. So you see how it sets that. So basically, it's actually enabling eBGP multi-hop in the background anyway. So it says incoming TTL 250. So does that mean that you have to have the minimum incoming could be 250? Basically, what you want to do is you want to subtract the maximum TTL, so 255, from however far away or how many hops your particular peering is. So that means if your peering is only 5 hops away, that means you're going to want to subtract not 5, but 250. So that your peering is literally 250, minimum incoming TTL is 250. So I'm going to go in here and exit. I'm going to modify this real quick. And we're going to say that is going to be 250. Same thing on this side, and 250. And if we do a do clear IPBGP 14.15.0.15, we should form a peering. Let's see, do show IPBGP summary. I'm actively trying to form the peering. Let's see here. Is it giving me an issue over here? Do show IPBGP summary. No, it's definitely up. It says it's been up for 2 minutes and 49 seconds, and I've received 13. I've received. Okay, it's up there, and it's. See, this is why I don't like this command, because it's really flaky, as you can see. Now I'm forming the peering, as you can see. I'm getting a bunch of routes installed, and if I type in do show IP, if I hit the command again, I should have a peering, and I'm good to go now. So this is why I don't trust this command, but I just wanted to make sure you guys understood that. So now if we do a do show IPBGP neighbor of 14.15.0. Go in here before it freaks out on me again. Oh, there it goes. Actually, no, that's an update. 15 pipe include hops or TTL. So minimum incoming TTL is 5, which is how you'd want it to be. So I don't want it to be any more than 5 hops away. So if I try to form a peering or do some sort of BGP attribute from this particular peer, it will fail because the TTL value is set incorrectly. So that's how I would go about doing it. TTL security is just one of those aspects that you'll get tested on and you want to know how it works. So that's why we're covering it. You won't see me utilizing it at all as we move forward here. Just be aware of that it does, how it works, and that its syntax and stuff like that. Play around with it. You can see in the Wireshark captures, you'll see the TTL set outbound, but as you can see, it's set outbound here as well. So it'll set it to the TTL of 5 and the outgoing updates all as well.